Okay, so let's start doing some examples of where we convert polar functions, right, into rectangular functions, functions in the rectangular plane. Okay, so we're going to use the formulas just like we did in the last example with the circle. We're going to transform these other functions into equations in the rectangular plane, and we'll identify the graph as well. So in this case here, let's look at what's going on here. We have this equation that says theta equals pi over 3. Okay, so that's a 60-degree angle, right? So, but notice that there's no r in here, right? So what this is saying is we can let r be anything and it doesn't even matter. The angle will always be pi over 3. So whether the r is 0, or whether r is 3, or whether r is 10, or whether r is -1, or -7, or -100, the angle will always be pi over 3. Which means this is going to be the equation of a straight line. Okay, so you can think about this, and so in fact, any equation of this type where theta equals k is always going to be a straight line that goes through the pole of the plane, of the polar coordinate system. Okay? So we can see, we can recognize certain things right away if we're paying attention. But let's change this to the rectangular coordinate system. So what do? Well, first thing we do is we've got theta here, so let's just take the tangent of both sides, right? So let's take tangent theta equals tangent of pi over 3, okay, or tangent of 60 degrees, right? Well, what's the tangent of 60 degrees? So you should remember, right? So remember the tangent of 60 degrees, right? Pi over 3. So tangent of 60 degrees is adjacent over hypotenuse. Or not adjacent over hypotenuse, opposite over adjacent. Okay, so what's the opposite? Opposite here is square root of 3. And what's the adjacent? The adjacent is 1. Okay, so tangent of pi over 3 is equal just to the square root of 3. And so we get tangent theta equals the square root of 3. Well, what's tangent theta? Well, that's just y over x, right? And so we get y equals what? The square root of 3 times x. What is this the equation of? This is the equation of a straight line where the slope of the line is square root of 3 and the intercept is 0, so it goes through the origin with a slope of square root of 3. Isn't it what we were saying? In fact, any function of the form theta equals k is going to be a straight line that goes through the origin with a slope of the square root of what? The square root, or excuse me, I'm sorry, not the square root, it's going to be the tangent of k. So in this case here, anything with this formula is going to be equal to y equals mx plus b, where b is equal to 0 and m is equal to the tangent of k. And that's it. We'll do another one next time.